We are now going to take a look at how to graph a quadratic equation. To graph a quadratic equation, we are going to follow these 4 steps. The first step is to find the axis of symmetry, which we did in the last video. The equation for my axis of symmetry is x equals the opposite of b over 2a. From that, we then find our vertex. In our vertex, the x value, it comes from our axis of symmetry, the opposite of b over 2a. And to find the y value, we plug that in. So how we labeled that before, plug it in. Step 3 tells us to put the vertex in the middle row of the table. Fill in a table of values using your calculator, and then lastly, plot the points and connect them into a smooth parabola. So let's look at the examples here. The directions say, graph each quadratic equation using a table. Identify the axis of symmetry, vertex, domain, and range. Number 1, y equals x squared plus 2x minus 1. According to the steps above, step 1 tells us to find the axis of symmetry. X equals opposite of b over 2a. As I look at my quadratic equation here, my a value is 1 and my b value is 2. So to find my axis of symmetry, I have x equals the opposite of b, so negative 2, over 2 times my a value of 1. So that gives me negative 2 over 2, which is negative 1. So the equation for my axis of symmetry is x equals negative 1. To find my vertex, I use that x value of negative 1, and I plug that in to my equation to find my y value. So negative 1 squared plus 2 times negative 1, subtract 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. Subtract 1. 1 subtract 2 is negative 1. Subtract another negative 1. Subtracting 1 is negative 2. So my vertex has an x coordinate of negative 1, and after I do my math there, a y coordinate of negative 2. That vertex goes in the middle of our table. So negative 1, negative 2 is our vertex. That's what drives our values in our table. Because negative 1 is the middle value of x, I'm going to go 2 values less than it and 2 values greater than it. That will be the case every time. Now from those values, x values, I need to find the y values. Just like we did on the vertex to find the y value, we plug it in, we do the same thing here. So let's start with negative 3. Negative 3 squared plus 2 times negative 3, subtract 1. Negative 3 squared is 9. 2 times negative 3 is negative 6. Subtract 1. 9 subtract 6 is 3. Subtract 1 is 2. So when x is negative 3, y is 2. Now I'm going to plug in negative 2. Negative 2 squared is 4. 2 times negative 2 is negative 4. And then subtract 1. 4 subtract 4 is 0. Subtract 1 is negative 1. Now I'm going to substitute 0 in. 0 squared is 0. 2 times 0 is 0. 0 plus 0 is 0. Subtract 1 is negative 1. And lastly, let's substitute 1. 1 squared is 1. 2 times 1 is 2. Subtract 1. 1 plus 2 is 3. Subtract 1 is 2. You will notice something on your table. If done correctly, these y values will be the same. And these y values will be the same. So let's plot these points. -1, -2 is our vertex. -2, -1. -3, +2. 0, -1. 1, +2. And then we connect those with making a smooth parabola. Not the easiest thing to do with my finger. Okay, that's not too bad. Okay, don't forget we need domain and range. Domain and range we talked about last week as well. Domain are the possible x values of our function. So think about it. Could I put any x value in on my table? And the answer to that is yes. All parabolas, all quadratic functions have a domain of all real numbers. Another way to think of it is my graph goes forever to the left and forever to the right. My parabola is getting wider and wider. Range. Range goes with my y values. Okay, how low does my graph go? Okay, that looks like my low point. -2 is the low point of my y values. How high does my graph go? My arrows tell me it goes forever up. So my range is going to be y values, because it goes forever up, greater than or equal to, and then the y value of my vertex, -2. Lots of steps are involved, but you can see how they all fit together in the end. Let's look at number 2. Y equals -x squared minus 8x minus 17. Let's first find the equation of our axis of symmetry. My a value in this quadratic is -1. My b value is -8. So to find my axis of symmetry, x equals the opposite of b. B is -8, so it's going to be a +8 over 2 times -1. 8 over -2 is equal to -4. So my axis of symmetry is x equals -4. That gives me the first half of my vertex. So I need to substitute -4, plug it in to my equation. Super duper important to substitute that -4 in parentheses and really watch your signs. -4 squared is a +16, but then I have a negative out in front, so that makes that -16. -8 times -4 is a +32. Subtract 17. -16 plus 32 is +16. Subtract 17 is -1. My vertex is -4, -1. That's going to drive my table. My vertex goes in the middle of my table. because my vertex has an x value of -4, I'm going to use that to determine the other x values of my table. I'm going to go down 2 and up 2. Now take a moment to select pause. Substitute those values into your equation to find the y values. If done correctly, you will again notice some repeating x values. If your x values do not repeat in such fashion, either you might have calculated the vertex incorrectly and therefore your table was set up wrong. But if you got the vertex of -4, -1, and your y values didn't correspond on your table, double check your work. Let's take a moment to plot those points on our graph. -4, -1, -5, -2, -6, -5, -3, -2, -2, -5. Let's connect. As you can see, my parabola points down. Does that make sense? Well, if we look at our quadratic equation, my a value is negative. I have a negative out in front, which tells me my graph is going to open down. All right, domain and range. What is our domain for every quadratic equation? All real numbers. My range. Okay, this is my high point. Okay, my high point has a y value of -1. So my range is y values, because my graph goes forever down, less than or equal to -1. That's a lot of work to graph parabolas, and typically we would spend some time doing that. But because of our shortened year this year, we can use Desmos to graph as well. So let's do number 3 with Desmos. So y equals -2x squared. So I'm going to bring up Desmos. Y equals -2x squared plus 4x plus 1 plus 4x plus 1. Haha! Look how much quicker that was than our method. We don't always have the capabilities of pulling up Desmos to be able to graph, but for these purposes, we do. So as you can see, my vertex is labeled by the coordinates 1, 3. Let's fill that in on our chart. 1, 3. If my vertex is 1, 3, I can now go backwards to find my axis of symmetry. Because the x value of my vertex is 1, the equation for my axis of symmetry is x equals 1. My vertex is going to drive my table 1, 3. The x value of 1 means my other x values are going to be 0 and -1, +2 and +3. Let's go back to Desmos to see if we can find those y values. Zero, 1. And we can see not exactly, but we can know where this is going to happen. That's 2, 1. So 0, 1, 2, 1. All right, let's see if we can find the corresponding y values when x is -1 and 3. Okay, when x is -1, right here. Looks like we're going to get -5. And when x is 3, we're also going to get -5.